video, I am going to show you how to solve a differential wave function using the chain rule formula for the derivatives. Now, our formula for the derivative using the chain rule is this one. We have the capital F prime of x is equal to small f prime of g of x multiplied by the derivative of g prime of x. Now, we should remember that this formula can be used when a function is considered as a composite function. Now recall that a composite function can be written as just like this: f of g of x or f of g of x. Okay, now for number one, here is our example. We have the function f of x equals to the square root of x cubed plus 1. Now, take note that this function can be considered as a composite function, f of g of x, wherein the function equals function f of x, or wait, this is f of g of x equals to square root of x cubed plus 1, where our f of x is equal to square root of x, while our g of x is equal to x cubed plus 1. Now, we should remember also the derivative for the square root f of x, or square root of x, is 1/2 times x raised to negative 1/2, while the g prime of x is equal to, we have 3x squared plus 0. So the derivative f prime of x is equal to the derivative f prime, or this f of x right here, which is 1/2. Then according to our formula, the g of x is inside f prime, so that is x cubed plus 1 is to negative 1/2, and then multiplied according to the formula, multiplied by the g prime, which is this one, 3x squared plus 0, or 3x squared. Now we can simplify this one just like this. We have 1 over 2 times the square root of x cubed plus 1, which is the negative 1/2 power simplified, multiplied by 3x squared, or 3x squared times 1, or 3x squared over 2 times the square root of x cubed plus 1. There you go. That is the answer for example number 1 using the chain rule formula for the derivatives. Okay, now for our next example, let's delete this one. Okay, for our next example, we have number 2. Now for this function, we have y is equal to 5 minus x raised to 4 cubed. Remember, this can also be written as a composite function f of g of x, where f of x is equal to x cubed and g of x is equal to 5 minus x raised to the 4th power. Our f prime here is equal to 3x squared, and our g prime here, this is g prime, is equal to 0 minus 4x cubed. Okay, so by using the chain rule formula, we have y prime equals to, first, the derivative of f prime, or f that is 3x squared, but remember, we write the g of x inside f prime instead of just x according here. So we have, that is 3 times 5 minus x raised to the 4th squared, multiplied by the derivative g prime, is negative 4x cubed. So let's simplify this one. We can write this one as negative 12. So 3 times 4, then x cubed, and 5 minus x to the 4th power squared. That is the answer for number 2. There you go. Okay. This is answer number 2. Okay. Now for number 3. Okay, it's for number 3. Okay. So for number 3, we have the function y is equal to tangent of x squared. Now this also can be expressed as a composite function, f of g of x, wherein your f of x is the function tangent x and g of x is equal to x squared. Now we know that the f prime, or the derivative of tangent, is secant squared of x, while the g prime of x is equal to 2x. So therefore, we have here for number 3, y prime, using the chain rule formula, we have the derivative of f prime, so that is secant squared. So that is secant squared. Then copy g of x, so that is x squared. Okay. Then multiplied by derivative g prime, so that is 2x. Okay. So let's simplify this one. So this is 2x secant squared of x squared. Okay, so that is how you calculate a differential of a function using the chain rule formula. So this is our answer. This one, so you have y prime equals to 2x times secant squared of x squared. Thank you.